Today we will look into linear regression. Up until now, all of our equations were linear or quadratic, where all the points, all the ordered pairs representing the values were on a same line or same curve. In a real-life scenario, you might see points that are scattered. So we will use scatter plots to determine whether there is a relationship between paired data. Scatter plots can show trends in data. If the y tends to increase as the x increases, then you have a positive correlation. If the y is decreasing as the x value is increasing, then you have a negative correlation. If there is no significant identifying points to say that whether y is increasing or decreasing as the x increases, then we will say there is no correlation. Another way of saying this would be, if you see a line where slope is positive, then you have positive correlation. Where slope is negative, we have a negative correlation. If there's no slope, then no correlation. Sometimes, by just looking at the scatter plot, we can create a line that could possibly represent the scatter plot. And these type of line is called line of best fit. That's the data that can best represent the situation. Let's look at our x and y values and graph them. We have x1, y2, x1, y3, x2, y4, x3, y4, x3, y5, x4, y5, x5, y5, x5, y7, x6, y8. Now, after plotting the points, we can identify the correlation. As the x value is increasing, the y value is also increasing. The data has positive correlation, positive slope. Now we're going to sketch a line of best fit. There is a way to sketch a line of best fit. Your line of best fit should be splitting the data evenly above and below the line. We know that we won't be able to draw a line that's going to represent every point in here, but we can try to make it as close as possible. Now let's start from 2. I select 2 as a good random starting point. I'm going to try to draw a line where it continues, and it's going to be splitting the data into two parts where almost half of the data is above the line and almost half of the data is below the line. And when I look at my graph, I see that 1, 2, 3, 4, 5 points are above the line and 4 points are below the line. So I did split my data almost halfway, and my line is somewhat representing the trend on the points, on the data. That was our step 2. Now we are going to look at step 3, identify a couple points on our own so we can actually find the equation and find the slope of this line that we created. I have my y-intercept, that's my first good point, and I look at other points, and here's another nice point that I can use. Now I will use this slope formula to find the slope of the line that we created. M is equal to y2 minus y1 over x2 minus x1. That would be x7 y8, y2 minus y1, 8 minus 2 over x2 minus x1, 7 minus 0, and I have 6 over 7 as my slope. Use point slope or slope intercept form derived equation. Since I know my b is equal to 2 and I know the slope is 6 over 7, I can write the equation y is equal to 6 over 7x plus 2. Now this is how we could write a equation of a line of best fit. This may not be the best fitting line. If you try to draw your line on your own, yours might be slightly different, where your answer might be slightly different as well. So it's okay to be approximate on these equations. That's why now, as a next step, we're going to learn how to do these with a calculator to find the line of best fit. Before we look into the calculator, let's try to graph one more, and let's try to identify points and identify correlation, sketch a line of best fit, and find this equation. We're going to put our x and y values on the graph. It looks like our graph is not going to fit everything in nicely, so we're going to scale the graph where each unit represents 2 points. Ten, 20, 30, 40, 50. When x is 28, y is 16, x 28, y 16. When x is 35, y is 13, x 35 is in the middle, y 13 is in the middle. When x is 8, y is 2, x 8, y 2. When x is 20, y is 12, 20 to 12, that's another point. When x is 39, y is 31, 39 to 31. 23 to 10, 23 to 10. 19 to 9. 27 to 15. 27 to 15. 15 to 4. And 30 to 19. 30 to 19. Now we graphed all of our points. We're going to create a line of best fit. When we graph our line, we're going to try to represent the cluster as best as possible. It looks like as the x values are increasing, y values are also increasing. So we have a positive correlation. So identify the correlation. We identified it's positive. Sketch a line of best fit. When we sketch the line of best fit, we are going to try to pass through as many points as possible. Also, we are going to try to separate the data in the two parts where almost half of the data is above the line and almost half of the data is below the line. So if we start from here and then try to draw a line passing through these points, and try to draw as straight as possible, and I have passed through as many points as possible, and it looks like we have 3 points above the line, 4 points below the line, so almost the same. We're going to use some of these points to create the equation of the line. Now I will use 2 points on the line. One is going to be this one, and let's say the other one is going to be this nice one here. 2 points that I will use are x 10, y0, and the other point is x30, y19. By using these 2 points, I can find the slope. Slope would be 19 minus 0 over 30 minus 20 is equal to 19 over 10, which is equal to 1.9. So I can write my equation, but prior to writing the equation, we also need to decide which form to write the equation in. Let's write the equation in point slope form. If you remember point slope form, it was y minus y1 is equal to m times x minus x1, where x1 and y1 were a point. So let's say that we want to select one of the points as x and y values, x1 and y1, and plug them in here in our equation. We would have y minus 0 is equal to m times 1.9 times x minus 10. So y is equal to 1.9x minus 19. 1.9 times 10 made 19. It looks like we have found our equation in slope-intercept form. We have found the slope, and we have determined as positive correlation, and as you can see with the positive correlation, our slope is also positive. So far, we have found the best fitting line. A best fitting line is the line that follows the trend as close as possible. The whole process of best fitting line is called linear regression. We can perform linear regression using technology. We will use calculators. Using a line or its equation, we can approximate the values between two known values or values that are not within the range of the x values. So if we have x values, let's say 1 through 20, and if you have all the integer values, and if you want to find the approximated value of x is equal to 1.75, which if it's not in your domain, then it's called interpolation, because we are looking for a value that's within domain. And if we are trying to find a value where all the x are integers, 1, 2, 3, going through 20, or 30, doesn't matter. In this case, I'm just making up numbers. And if I want to find what would be the value for 35, that's not within the range, these type of approximations are called extrapolation. So when we look at our value, if the value is within the domain values, interpolation. If it's beyond the domain values, then it's called extrapolation. Either way, it's just a fancy name for it, but we will just find interpolation or extrapolation points with the same process, which is linear regression. Now we will use the calculator to find and perform linear regression, to find the equation and perform linear regression. We have the data given, and we are going to enter the data in a calculator where x is going to be number of years and y would be CDs. Because the years start from 1993 to 1997, I will make time 1993 to be year 0, and this would be year 2, this would be year 3, this would be year 4. We can make the scatter plot of data. Let's make these represent by tens. When t is 0, it's 7.8. When t is 2, it's 22. When t is 3, it's 43. When t is 4, it's 67. One, two, three, 4. It looks like we did some of the points incorrectly. Let's start over. When t is 0, it's 7.8. When t is 2, it's 22. 2 will be 22. It's right here. And 3 would be 43. That would be right here. And 4 would be 67. I will put 67 over here. Now we can try to find an equation to represent the situation. Our line of best fit would be a line represents this system, and almost half of the points are above, almost half of the points are below the line. And my closest line is going to be this one, where I actually put a new point to identify my line, and so I can find my slope. Slope from 7.8 was my y-intercept. It looks like that's also not a pretty point. Let's just use this point in here because we're just doing approximation. I will use 30 till 70, x, and a t is going to be 2 to 5. We're just going to see how accurate we can be versus the calculator. So slope of this line that we created up 4 over 3, m is going to be 4 over 3. M is equal to 4 over 3. And y-intercept is 7.8. I can say equation is y is equal to 4 over 3x plus 7.8. That's my linear regression equation. Now we are going to do the same thing with the calculator. On calculator we have certain steps. We will go over these steps in the class for those of you who don't have a calculator access at home. First you will enter stat, and then we will hit edit button. That's the first choice. And on the edit we are going to put L1 as the x values, L2 as the y values. We're going to enter all the values. And we're going to hit stat again. This time we will, instead of clicking edit, we will move to the next bar and hit calculate. At this point, under the calculate, you should be able to see linear regression, and we will hit linear regression and hit until you get an A value and B value. The equation of the linear regression equation gives us an A value and B value, and A is approximately 14.45 and B is approximately 2.43. This gives us the equation in y is equal to mx plus b form, ax plus b form. Y is equal to 14.45 x plus 2.43. Now it looks like it's way off from our equation, and when I look at the slope that we have found, up, instead of going up 4, I should have gone up 40 over 3, and our slope would be 40 over 3. 40 over 3 is 13.3 repeating. So if I were to approximate this, I would write y is equal to 13.3 repeating x plus 7.8. And as you can see, our equation that we manually found is almost representing the best fit that could be found with the calculator. And how does this equation compare to my line of best fit? Of course, calculator is more accurate. but they do both have similar slopes. Use the equation to approximate the number of CD shingles shipped in 1994 and 2003. This would 1994 would be when T is equal to 1. 2003 would be T is equal to 10. Calculating f of 1, in this case the function y is equal to 14.45 plus 2.43, we will do y is equal to 14.45 times 1 plus 2.43. This will give us the value or number of singles shipped in 1994. We got 16.88. Likewise, I can find the singles shipped in 2003 by plugging 10 instead of x. Y is equal to 14.45 times 10 plus 2.43. This y value will be equal to 147.43. So we can find values that are within the range, within the domain values. First one would be an example of interpolation, and second one would be an example of extrapolation. Here are the calculator steps. Those of you who have a calculator access at home, please try these on your own. Use your x values and y values into L1 and L2 and follow the steps to find the linear regression equation. Those of you who don't have a calculator access at home, we will go over this in the class. That's pretty much it. Please bring any questions you might have to the class.